Hello, in today's video, I'll be solving questions on A2 Electrochemistry from May-June 2019, paper 4-1. Question 2, C. A lithium iodine electrochemical cell can be used to generate electricity for a heart pacemaker. The cell consists of a lithium electrode and an inert electrode immersed in body fluids. When current flows, lithium is oxidized and iodine is reduced. I. Use the data booklet to write half equations for the reactions taking place at the two electrodes. Hence, write the overall equation for when a current flows. So first, let's pick the half reactions from the data booklet. So for iodine, this is the half cell equation. And for the lithium equation, this is the half cell equation. The electropotential for the lithium plus to lithium half cell equation is negative 3.04, and that of the iodine half cell is plus 0.54. So from the data booklet, all the half cell equations are written in the reduction form. And again, reduction is the gain of electrons. So the lithium plus is gaining electron in this case, and then the I2 is also gaining electron to undergo reduction. And so from the question, we can see that they say lithium is oxidized. And so if you are supposed to write the half cell equation for this to answer this question, it means that we have to reverse this lithium equation. And so this will be Li giving us Li plus E minus. And from the question, iodine is reduced. And so it means that since the iodine is already written in the reduction form, you just have to maintain that equation. And so that will be Li2 plus 2E minus, giving us 2I minus. Overall equation. Now, for you to write the overall equation for these two half cells, it means that you have to add the two half cells together. However, for you to add two half cells together, you have to make sure that the number of electrons transferred in both equations are equal. We can see that for the I2 equation, the number of electrons is 2, but for the lithium equation, the number of electrons is 1. So to be able to write the overall equation, we have to multiply the lithium equation by 2. So this will be times 2 here, that will be 2Li. Then this will be times 2 here, 2Li plus, then times 2 electrons. So that will be plus 2E minus. And so once we have been able to multiply this through with 2, we can now add the two equations. So this will be 2Li plus I2 giving us 2Li plus 2I minus. Now the number of electrons at both sides of the equation is 2, so that's why we cancel them out. And again, in writing the overall equation, we added the reactant side of this first equation to the reactant side of this first equation. And on the other side here, we added the product side of this equation to the product side of this equation. Use the data booklet to calculate the E naught of cell for this cell. This cell equation was gotten by adding these two half cells together, where the lithium half cell was reversed in order to get the cell equation. So it means that the E naught of cell is equal to the sum of these two electropotential values. That of the lithium was reversed. So it means that you have to reverse the sign of the electropotential value for lithium. And so that will be 3.04 volts. Then plus that of the I2 equation was still maintained in the cell equation. And so that will be plus 0.54 volts. And this gives us plus 3.58 volts. I. A current of 2.5 times 10 power minus 5 amps is drawn from this cell. Calculate the time taken for 0.10 grams of lithium electrode to be used up. Assume the current remains constant throughout this period. In this question, we are supposed to calculate the time taken for 0.10 grams of lithium electrode to be used up. And so we use two equations over here. The first one is Q, which is the quantity of charge, is equal to IT, current times time. And this has a relationship with the mass of the lithium electrode used up. And so this must be equal to 0.10 grams. Because for this mass to be used up, this current was used for a certain time that we are supposed to calculate. So our current is 2.5 times 10 power minus 5. We don't know the time, so we maintain it as T, and this is equal to 0.10 grams. This is equation 1. For us to use the second equation, we need to write the half cell equation for the lithium. And so lithium plus A minus gives us Li plus. In this equation, only 1 mole of electron was passed. And so this corresponds to 1 Faraday. And 1 Faraday is equal to 96,500 coulombs. Now, for this charge to be passed, there is a certain mass of lithium that was used up, and we need to find the mass of lithium used up. Amount is equal to mass over molar mass. The amount of lithium used up is 1 mole, and so we put 1 here is equal to the mass divided by the molar mass. And in this case, the molar mass of lithium is the same as the atomic mass, and so that will be 7 grams per mole from the periodic table. So it means that the mass of lithium used up is 1 times 7, and so that will be 7 grams. So from this equation, our mass is 7 grams. So that means we have 96,500 coulombs corresponds to 7 grams, and this is equation 2. So we can use ratio and proportion on equation 1 and equation 2 to find T. 2.5 times 10 power minus 5 T is equal to 0.10 grams. So if you cross multiply, we get 7 times 2.5 times 10 power minus 5 T is equal to 96,500 times 0.10. And so we divide everything through with 7 times 2.5 times 10 power minus 5. This one, 7 times 2.5 times 10 power minus 5. And so when you do that, T gives us 5.5 times 10 power 7 seconds. Thank you for watching, and see you again in the next tutorial.